Welcome to the session. So today's topic is the octal, hexadecimal and binary coded decimal, that is a BCD number system. So let us have some overlook on this, or we will have some overlook on this octal, hexadecimal and binary coded decimal, that is BCD number system. Myself Ajit Subhas Suryawanshi, working as an assistant professor in a program Electronics and Telecommunication Engineering. So learning outcome of this session is at the end of the session, student will able to perform the operations on the digital numbers. That means interconversion of these numbers, addition subtraction if it is in the addition subtraction in the hexadecimal BCD numbers are there. So prerequisite means what should the knowledge you should have possessed that before proceeding to the session. So student must have a basic knowledge of the real number systems and its arithmetic operations. So you should have a knowledge of the real number systems. So real number systems includes integer, decimals, rational, irrational numbers, and its arithmetic operations means it is addition, subtractions, multiplication, division. So you should have a knowledge of that. So to have the knowledge, you can able to learn the different number system. So once again discuss the number systems. So in the number systems, so these are the symbols in the number systems. If it is a decimal number system, there are 10 symbols. And if it is a hexadecimal number system, there are the 16 symbols. So depending upon the number of symbols, the base is defined here. So for the decimal base is 10. So you can expand this number systems by using this. So this summation is for the integer part, means the numbers which is before the decimal point or any other point, so dot point, and these are the summations for the fractional part. So numbers are after the decimal points, right side of the decimal point or any other point. If it is the binary number system, then it is a binary point. If it is hexadecimal number system, then it is a hexadecimal point. So depending upon that, we are going to define that dot, so dot operation. So depending upon this weight, you can define this this position, that is means this is at the 0 position, this is at the 1 position. We can define the weight of that. So if it is base is a 10, then it is a 10 raised to 3, it is a 1000. And if the base is 2, then it is 2 raised to 2 raised to 2, it is a 4. And if the base is 10, it is 10 raised to 2, that means 100. So this is defined for the decimal number systems, and obviously these are the digits, means which are the symbols may possible in the decimal number system. So there are 10 symbols possible in the decimal number system, that is 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the basics of number system. So you can define any number system by using this by using this equation, this summations for the integer and this summation is for the fractional part. So let us have a look on the octal number system. So in the octal number system, it is octal name itself suggests octa means it is including the 8 symbols in it. So 8 symbol, that means it has a base 8. So number of symbols actually define its base. So base decimal number system have a 10 symbols, so base of the decimal number system is a 10. Binary number systems have a base of 2, that means it has a 2 symbols and its base is a 2. So similarly, so which are the symbols in the octal number system? 0, 1, 2, 3, 4, 5, 6, 7. So these are the 8 symbols starting from the 0. So these are the symbols actually used in the octal number system. So octal number systems can easily be converted from the binary numbers by grouping the binary numbers from the right hand side. So you have to make a group of the 3 bits. Okay, so you have to make a group of the 3 bits, 3 binary digits, and after that grouping, you can have that particular you can have that particular or you can convert your binary into the equivalent octal number system. So for example, so this is a 74 is a decimal number, so it can be represented in terms of the binary. So you can start grouping from the right hand side. So from here, so 010 is the one group, then 001 is one group, and last only one digit is remaining, one binary bit is remaining. That means you can append extra zeros here. So now you can convert this into the equivalent octal number. So it is 1 1 2. Okay, so the octal number for this binary number is 112. So octal number actually representing the numbers 3-bit binary equivalent number. So let us have that look into this binary first of all. So octal to binary, all symbols to octal to binary. So let us have some examples. So you can represent 124 is an octal number system. So how you can convert it to the equivalent decimal number system? So 4 has a weight of, so as this number system has a base of 8, so it has a weight of 8 raised to 0, it has a weight of 8 raised to 1, and the last digit has a weight of 8 raised to 2. So when you calculate this, you will converting this the octal number into the equivalent decimal number. So these are the octal numbers and its equivalent binary numbers. So 0, 1, 2, 3, 7. So 0 is represented by the 3-bit binary as a 000, and 1 is represented as a 3-bit binary as a 001. 2 is represented as a 010. 3 is represented as a 011, and 7 is represented as a 111. So 3-bit binary equivalent is used to represent the octal number. So let's have on the hexadecimal number system. So hexadecimal name itself suggests hexa means a 6 and decimal means a 10. So 10 plus 6, it is a 16. So there are total 16 symbols involved in the hexadecimal number system. So which are those 16 symbols? So that's why the base of this hexadecimal number system is 16. Similar to the decimal number system, base of the decimal number system is a 10. So it uses a 16 distinct symbols. So 0 to 9, same as our friend decimal number system, plus it is including the more symbols. So it taking the letters. So these letters are A, B, C, D, E, F. So these are the 10 symbol plus this 6 letters, that is A, B, C, D, E, F. So including all the symbols, hexadecimal number systems is defined. Okay, so now you can compare hexadecimal to the decimal. Decimal have only 10 symbols, hexadecimals have a 16 symbols, and the 6 symbol extra are the A to F to represent that numbers 10 to 15. Okay, so each hexadecimal digit is represented by the 4-bit binary digit. So it is also called as a nibble. Nibble means a group of 4 bits, 4 binary digits. So which is a half of byte. Byte means a group of 8 bits or 8 binary digits. So these are the binary equivalent for the binary equivalent of the decimal and its hexadecimal number. So 0 is represented as a 4-bit binary as a 00000, and its hexadecimal is a 0, and last symbol in the hexadecimal number system is F. F stands for the 15 in the hexadecimal number, 15 in the decimal number system, and it is represented as a 1111. That's 4 times 1. So 4-bit binary representation of the hexadecimal number system. Please remember a 3-bit binary representation for the octal number system. So one more thing is a binary coded number system, binary coded decimal number system. So in the binary coded decimal number system, name itself suggests it is coding of the decimal number system individually. So individually means digit by digit. So you are converting it to the binary equivalent. So which are the decimal, you are already aware. That means which are the symbols in the decimal number system 0 to 9. So all 0 to 9 is converted to the equivalent 4-bit or 8-bit binary numbers individually, instead of converting it to the straightforward. So position conversion is there. So that converting into the straightforward, that means every digit is converted into the equivalent binary. So BCD is give a convenience of it can be easily readable, so for humans. So that's why the BCD is used. So these are the BCD that means BCD code is also called as 8241 code, and every decimal digit is represented by the 4-bit binary equivalent. So 0 decimal digit is represented as 0004 for the 4-bit binary coded decimal. Similarly, 1 is represented as a 10001. So this is, we are often converting the decimal digit to a equivalent binary number. So do you think that decimal number and the BCD numbers are the same? So when you convert a decimal into the binary and decimal into the binary coded decimal, so is that same? So think about it. You can pause this video and you can answer it is yes or no. If it is yes, you can have your reasoning for that. So no, because binary coded decimal is every decimal digit we are converted into the 4-bit binary as compared to the straight decimal to binary conversion. Okay, so that's why the binary coded decimal is different than the straight binary conversion. So these are the references for this session. Thank you.